Hey everybody, this is MoBaller12 here to help quench that knowledge thirst. For this video, I'll be specifically discussing what a mole is, okay? A quick little update. Check out my Facebook fan page. Link is in the description box below. Like it, support it, spread the word, spread the word about my Facebook fan page and about my channel. Show your love and support, like it. Also, I've been talking for the past few weeks about this new series, and I decided that I'm going to go ahead and follow through with the new series. So go ahead and start uploading or posting your questions or uploading videos with your questions on my Facebook fan page, and then I'll make a video on Wednesdays answering those specific questions. Probably I'll select three questions. Right now my channel is a little bit slow, so I'll probably start off with one or two depending on how many people I get, but eventually once the semester comes around, because I believe everybody's on a winter break, I'll start uploading more videos, okay, in regards to the new series. And if you don't know what I'm talking about in regards to the new series, check out my video quickie update. I'll put a link in the top right corner of this video. In that video quickie update, I'll give it more in-depth detail about that new series, okay? Oh, and in regards to the questions that you guys upload, please keep it relevant to the topics I am discussing on my channel. So currently I'm discussing general chemistry and organic chemistry topics, so keep it relevant to that. I mean, don't post a physics question or biology questions, because I haven't uploaded any videos in regards to that. It just kind of throws off things, okay? So keep it relevant to the topics I'm discussing. Eventually when I transition over to physics and biology and I start uploading videos on those topics, feel free to post questions in regards to physics and biology, okay? So for right now, keep it general chemistry and organic chemistry related. So the way I've segregated this video is basically in three parts. Basically, in the first part you have me discussing what a mole is, and the second part we'll be discussing what the molar mass is, and then the third part we'll be doing some calculations. And in regards to the calculations, let me zoom in on the top so you can see this, okay? In regards to the calculations, okay, let's see. In regards to the calculations, we're going to be grabbing some information from a topic I discussed in my video called it's called ionic and molecular compounds, okay? So I'll put a link to that when I get to this section, so you can check out those videos, okay? So like I said in that video, ionic and molecular compounds, that information is extremely pertinent, and you're going to see it throughout your chemistry lives. And here we go. We already have another general chemistry video that is starting off discussing about ionic compounds, and we'll talk about that a little bit later. I know it's a little bit confusing now, but just bear with me. So let's start off with the first thing, what a mole is. Now, a mole is extremely simple to understand. I made it complicated when I was a student in the introductory chemistry classes, but it's extremely simple. A mole, in its most basic understanding, most basic definition, is a quantity. It's an amount. It represents a specific number. Just like a dozen represents a specific number, a mole represents a specific number. Granted, we use the dozen more regularly, and that's why we're more comfortable with that term, but eventually we're going to condition ourselves to get comfortable with the term mole. So again, a mole in its most basic definition is a quantity or an amount. So again, 1 dozen of donuts, so there's a little example to get you guys conditioned to understand what a mole is. 1 dozen of donuts translates to 12 donuts. 1 dozen of cars translates to 12 cars. 1 dozen of phones translates to 12 phones, okay? So we have been conditioned to accept that a dozen translates to the number 12. It could be 12 of anything. So we could apply it to 12, we could have a dozen roses, dozen chocolates, dozen noses, dozen eyes, dozen human beings, so on and so forth. But it represents 12 things, okay? Applying the same logic, we could do the same thing for a mole. 1 mole of donuts represents this extremely large number. Let me zoom out just a little bit so we can see this, okay? So 1 mole of donuts represents this extremely large number, okay? Typically we don't write it out like that. We write it out like this: 6.022 times 10 to the 23rd. and this is in scientific notation. Hopefully you guys are familiar with scientific notation. Eventually, in the near future, I'll be uploading some videos on that, okay? But nonetheless, I hope you guys are familiar with this, and a mole represents this specific number. So if you have a mole of donuts, it's this extremely large number of donuts. If you have a mole of cars, you have 6.022 times 10 to the 23rd cars. If you have a mole of phones, it represents 6.022 times 10 to the 23rd phones, okay? Obviously, donuts, cars, and phones, a mole of those guys is not really important in the chemistry world, but I'm just trying to get you guys to understand what a mole is. So again, if we go down right here, if we look down right below this little description I have here, these examples, a mole is equal to 6.022 times 10 to the 23rd things. So I put that in quotation marks. And the things that we specifically see are atoms, molecules, ions, electrons, etc. It's specifically things relevant and pertinent to the chemical world, okay? We're not going to see donuts or cars here, obviously, but the whole point of this was just to get you guys to have an intuitive understanding of what a mole is. So again, just to solidify the understanding of a mole, just like a dozen equals 12 things, okay, a mole equals 6.022 times 10 to the 23rd things. Now the things in regards to a dozen is completely different to the things relevant to a mole, okay? The things that are relevant to a mole, again, are atoms, molecules, ions, electrons, etc. So that is a mole, okay? No, we're not talking about the animal. A mole is that specific number. Internalize it, memorize this number, make sure you know this relationship, that a mole is this number. Extremely important, Avogadro's number, okay? So now we're going to transition over to molar mass. Alright everybody, for this part I'll be specifically focusing on the molar mass and how that ties in with the mole, okay? So this is the part B. And you guys might be noticing that there's a change in brightness. I found a new little button on my camcorder that I pressed for the heck of it, and I noticed that it changed the brightness of it. So I'm going to start using that new function. So let's get right into it, okay? So we're going to transition and focus a little bit on the periodic table for a second. Let me zoom in. Let me zoom in a lot. Okay, there you go. That should be nice and clear. Let me go a little bit more. Okay, so as we already know, let me get my pen if I can find one. Hold on one second. There's the pen. As you guys can already tell, and you should know, that there's a few little things we could derive and understand from the periodic table. Obviously, that's the atomic number, represents the number of protons, and in this elemental state, it also could represent the number of electrons. That's not really important. What's really important in regards to molar mass is this number below. This is 19 AMUs, an atomic mass unit, 19 AMUs. But this number can also be represented. This also can represent the mass of fluorine in terms of grams per mole. So that's the molar mass. So again, this number represents both AMUs and also grams per mole. So we could have 16 AMUs or 16 grams per mole. It's another way of defining the mass of a specific element. So again, for sulfur, this could be 32.07 AMUs or 32.07 grams per mole. And I'll explain to you guys how scientists, I'll give you a brief little understanding of how everything works, okay? So again, just understand that this could be in units of AMUs. This numbers can be in units of AMUs or grams per mole to represent the specific mass. So let me describe what that means, okay? So here we zoom out a little bit. Here we have these values here for fluorine, chlorine, lithium, okay? For fluorine, we got this number from the periodic table. Again, we can use grams per mole or AMUs, but in this case, since we're talking about molar mass, we're going to be talking about grams per mole unit, okay? Units are extremely important in the field of chemistry, so you guys should know that. So fluorine is, again, 19 grams per mole. So algebraically, we could put a 1 here, and I'm trying to explain to you how this works and what does it mean. Basically what this means, again, algebraically we could put a 1 there next to the mole. Again, it's 19 grams per 1 mole, and we can do it for every single one of these guys. It doesn't change the mass or anything like that. Zoom in just a tad bit more. So what this is saying is that if we have 1 mole of fluorine atoms, that 1 mole of fluorine atoms will translate to 19 grams. So again, 1 mole of fluorine atoms equals 19 grams. What that 1 mole represents, we should already have internalized it. That represents 6.022 times 10 to the 23rd. So if you had that number right here, if we have 6.022 times 10 to the 23rd fluorine atoms, it represents 19 grams. That it weighs 19 grams. Okay, we could apply the same thing here. If we have 1 mole of chlorine atoms, that equals 35.45 grams. 1 mole meaning 6.022 times 10 to the 23rd. So it's basically saying that if we have 6.022 times 10 to the 23rd chlorine atoms, it equals 35.45 grams. If we have, again, 1 mole of Li atoms, it equals 6.941 grams. That 1 mole is 6.022 times 10 to the 23rd. That should make sense, okay? So again, 1 mole of Li atoms equals 6.941 grams of Li. 1 mole of Cl atoms equals 35.45 grams of Cl. 1 mole of fluorine atoms translates to 19 grams of fluorine. And this is the definition of this right here. Okay, this translates to this. So 19 grams per mole basically means that in order for fluorine to have 19 grams of fluorine, you need 1 mole of fluorine atoms. In order to have 35.45 grams of Cl, you need 1 mole of Cl atoms. In order to have 6.941 grams of lithium, right, you need 1 mole of lithium atoms. And that's all it means. Okay, so that's the molar mass. This specific number, this molar mass, which you can determine from the periodic table, as I have shown you, is extremely important when we're doing calculations. So that pretty much sums up the molar mass. Again, this is not that big of a topic, the molar mass. I mean, it's pretty self-understanding. I mean, it's pretty intuitive if you spend some time with it. And again, these numbers that I got straight off the periodic table. And again, those numbers can be in AMUs, but when we're doing calculations, we'll be talking in grams per mole. Okay, and this is an extremely important number. Every single molar mass that is on the periodic table is extremely important when we're doing calculations, specifically when we're trying to translate from mass to moles. And then for part C, that's where I'll be talking about specific calculations that is pertinent to this specific topic. Okay, so stay tuned for this final part where I discuss calculations dealing with molar mass and the mole. Welcome back, everybody, to the final part where I discuss calculations. In the top right corner of this video, just a quick little heads up, I'm going to put a link to my video called Ionic and Molecular Compounds, because it's an extremely important topic when we start doing some examples. So if you don't know that topic, ionic and molecular compounds, the whole naming ordeal with that and how to make ionic compounds, highly suggest you check those videos out before continuing with the rest of this video. Okay, so if you don't know how to make magnesium chloride, if I ask you to write out magnesium chloride in its chemical formula, you better be able to do that. If you can't, then it's going to be extremely hard when we start dealing with calculations. So again, I'm going to put a link in the top right corner to the first part of the series. It's a 5-part series. Okay, so let's get started with the whole calculation thing. There are 2 ways that we could do this calculation. We could start off with the mass and go to the moles, or we could start off with the moles and go to the mass. That's the second part. Okay, in the first part, what we do is, for example, A teacher could ask you, well, you have a certain mass. So let's just say you have 12 grams of carbon, your teacher could say, and I want you to find how many moles of that does that equal, okay? So in the first slot, we put the given mass of X. That's the mass that the teacher provides you with, so which is at 12 grams of carbon. Now, so you put that 12 in here. Now, in order to fill in these few slots up here and down here, you need to use the molar mass, and the molar mass is going to be inverted when you plug it in. It's not going to be, so for example, for carbon, the molar mass is, if you can see right there, carbon is 12.01. You're not going to put 12.01 on top. It's not going to be 12.01 grams per mole. You're going to put 12.01 grams on the bottom and the 1 mole on top, okay? So again, it's inverted molar mass. And eventually when you get the moles of X, that's how you do the first part, okay? And an extremely important topic that you should understand is dimensional analysis, okay? Dimensional analysis is extremely important when we're doing calculations in the field of chemistry. So I'll talk just very briefly about that. What is dimensional analysis, okay? I'll do it on the side right here. So dimensional analysis is a technique and method used to get your calculations out. So the whole point of it is you're going to cancel out units in order for you to get your desired unit on top. That's the whole goal. Get your desired unit on top, and that desired unit is going to be the answer to your calculation. So for example, just a brief little algebra we're going to talk about. If we have 10 over 10, that translates to 1. If we have 5 over 5, that translates to 1. If we have 10,000 over 10,000, that translates to 1, right? You guys get the drift. We could even apply that a little bit further. If we have x over x, that translates to 1. If we have x squared over x squared, that translates to 1. If we have 2x squared and 2x squared, that translates to 1. Okay? I hope you guys are getting the drift. We could even expand this a little bit further. We could put grams, the unit grams on top over grams on the bottom, and that cancels out to 1. We could put the unit moles on top and moles on the bottom, that cancels out to 1. So the whole goal of dimensional analysis is to cancel out units such as grams, moles. You know, units are basically that. They designate, they give definition to a certain number, okay? So we could cancel out units to get a desired unit on top. And once we get that desired unit on top, that's going to be our answer. So, for example, again, in order for you to cancel out one specific unit, you need to have the same unit on top as you do on the bottom, okay? So, for example, I'll do this right here very briefly. Just again, this is a little side note so you understand what's going on. So, say for example, we have, this is very, just to get you guys to understand the whole concept of canceling out units, okay? So, if we have grams here and grams there, and then we have moles here, okay? Actually, I'm going to write it out like that. That's going to confuse you guys. I just say we have grams here, then we multiply it by moles over grams, right? As you can see, the grams cancel out and you're left off with the moles on top. And that's the desired unit. And that's what you want to do. When we're doing calculations, you want to make sure your units cancel out. And that's a way for you to check your answer. And you get your desired unit on top. Now we can do the same thing. If we have moles and we have moles on the bottom and grams up top, the mole on the bottom and the mole on top cancel out, and we're left off with the grams. And that's the specific unit we're going to have to our answer, to our numerical value. So that's the whole point of dimensional analysis, canceling out specific units to be left off with one unit that gives definition to your number that you crank out in your calculator. And that's exactly what we're doing here in these formulas that I've shown you. Okay, as you can see from here, we have the grams of X on top and we have the grams of X on the bottom. They cancel out and we're left off with the moles of X, and that's what our answer is going to be, moles of X. Same thing applies to the bottom. We have the moles of X on top and the moles of X on the bottom. They're going to cancel out to give you the mass of X on top. And that's the whole point of dimensional analysis, canceling out things to get a specific unit that gives definition to your number. So make sure you understand how this works. Make sure you have an understanding of dimensional analysis, and we'll go through some examples so you get a better understanding of it. Okay, that's the best way you can understand dimensional analysis, by going through problems. Okay, so again, if you want to go from mass to moles, we put the given mass of X there in grams. If it's in kilograms, if the teacher gives you the problem in kilograms, you have to translate to grams, and you have to know your prefixes and your conversion factors, and I'm not going to go through all that in this video, but you should know that. And then we're going to have the inverted molar mass. The units are going to cancel out, and we're going to have the moles on top. The next part, if we want to go from moles to mass, the teacher could say, for example, we have 10 moles of carbon. How many grams does that translate to? Well, the given moles of X, which is X represents the specific element we're talking about. Again, X in this case represents the specific element we're talking about. So given mole of X will be 12 moles of carbon, right? And times it by the molar mass. We're not going to invert it. We're just going to put the number straight up from the periodic table. So it will be 12.01 grams of that carbon per 1 mole of carbon. Okay, make sure you designate the element. Okay, because you could get lost when we do some more complex problems. Okay, and again, the units cancel out, and you'll be left off with the mass of carbon if we're dealing with that specific element, carbon, on top. Okay, so that's that. Again, we're going to do some examples. So stay tuned where I address a bunch of problems with using this formula and using dimensional analysis.